In our country, favorable climatic conditions for mulberry cultivation prevails in the states like Karnataka, Andhra Pradesh, Tamil Nadu, West Bengal and Jammu Kashmir. These states occupy about 97% of total mulberry cultivation, contribute about 95% of raw silk production in India. Tamil Nadu is ranked 4th place among the silk producing state of the country. In 1956, sericulture was practiced in limited pockets of Coimbatore and Dharmaburi districts in our state, accounting about 500 hectares only. Then, with the implementation of many developmental schemes in the state, sericultural activity was introduced into. With the implementation of many developmental schemes in the state, sericulture activity was introduced into the plains of the state. From 1979, Department of Sericulture with the headquarters at Salem is functioning as Department of Industries and Commerce. The latest cost saving technologies, separate rearing room for silkworm, use of disinfectants and supply of chalky worms etc. was introduced by research institutions, helped the farmers to increase the productivity and income level. At present, 30,000 farmers are practicing sericulture in Tamil Nadu, cultivating about 35,000 acres of mulberry. Weaving sector comprises mostly of handlooms at Kanjipuram, Kumbakonam, Arani, Salem, Coimbatore, Madurai and Tirunelveli weaving centers of our state. Methods of propagation. The methods of propagation of mulberry are sexual propagation, vegetative propagation, micro propagation. The sexual propagation or seedling propagation involves the method comprises of recombination of genetic material resulting in family that differ from each other from their parent. This method is rarely practiced for breeding purposes in research institutes. Here, the flowers are protected from cross pollination and only controlled pollination is allowed. Problem associated with the seeding propagation are: some plants often produce few or no seeds, and some plants have duality period and the seeds are not clones of the parent. Desirable characteristics may be lost. Then lack of uniformity. Vegetative propagation. This is the most popular method adapted for commercial cultivation. The main advantages are: the desired hereditary characters can be maintained throughout. Large number of plants can be raised quickly and economically. Pest and disease resistant varieties can be grown. Easier, more convenient and more economical also. It shortens the time taken to attain the reproductive maturity. Demerits of the propagation method include: it may be expensive, it may be labor consuming, it can be a slow method, takes long time to root. Not all plants will root, so must use alternative method, example tissue culture. The vegetative propagation methods are cutting, grafting, layering. Coming to cutting, this is the most popular method of cultivation in South India. So, this method is adapted for growing varieties fully acclimatized to local conditions. It is one of the easiest methods. A cutting is a vegetative plant pot which is severed from parent plant in order to regenerate itself, thereby forming a whole new plant. Prepare cuttings with a sharp blade to reduce injury to the parent plant. Dip the cutting or rubbing in alcohol or a mixture of 1 part of bleach to 9 parts of water to prevent transmission of diseases from infected plant to healthy plant. Remove flowers and flower buds to allow the cutting to use its energy and stored carbohydrates for root and shoot formation rather than fruit and seed production. With the large leaved cuttings, that is rhododendron, and limited space in the propagation container, trimming up of half the leaf length can improve efficiency as well as light and air circulation for all the cuttings. To increase the number of roots or to obtain uniform rooting except on soft fleshy stems, use a rooting hormone, preferably one containing a fungicide. Prevent possible contamination of the entire supply of rooting hormone by putting some hormone in a separate container. In India, propagation through cutting is the most common method. It is restricted to varieties which are fully acclimatized to local condition. Plants which conform to the qualities chosen for multiplication, such as nutritious leaf, higher yield, quick growth, resistant to diseases and insect pests, and drought resistance are selected. Cuttings of 7 to 10 centimeters, usually of pencil thickness, with 3 or 4 active buds are prepared out of the central portion of the clone with a slanting cut. So, these cuttings are planted in the field directly or in nursery beds. When kept in nursery, all precautions should be observed in not allowing these cuttings to dry up. After 2 to 3 months, sprouted cuttings are transplanted in the main field depending upon the type of plantation to be raised. The demerits of this method are: under temperature condition, rooting and establishment may be slow. Grafting. Grafting is a technique of joining the parts of two plants in such a way that they unite and grow as a single plant. Scion, which forms the upper portion in the desired variety, and the rootstock, which forms the lower portion in a local hardy variety. This method is not popular because of laborious process, high cost and skill involved. Large number of planting materials cannot be obtained in a short period of time. The reasons for grafting include obtaining the benefits of the rootstock, hastening reproductive maturity, hastening plant growth, reducing nursery reproduction time, propagating clones that cannot easily be propagated by cuttings. Types of grafting techniques include whip and tongue, cleft grafting, graft small scions onto larger rootstocks, bridge grafting, approach grafting, repair grafting, cutting grafting, that is stenting, then herbaceous grafting. Layering. Stems still attached to their parent plants may form roots where they touch a rooting medium. Severed from the parent plant, the rooted stem becomes a new plant. This method of vegetative propagation, called layering, promotes a high success rate because it prevents the water stress and carbohydrate shortage that plague cuttings. Some plants layer themselves naturally, but sometimes plant propagators resist the process. Layering may be enhanced by wounding one side of the stem or by bending it very sharply. The rooting medium should always provide aeration and a constant supply of moisture. This method of propagation involves the development of roots from a stem while it is still attached to the mother plant. The rooted stem is then detached to be grown as a new plant. Such a rooted stem is known as layer. Merits of this method: simplicity. There is no fear of the roots getting dried up as in cuttings. Used to obtain a large sized plant in a short time. Used to fill in the gaps in the field where cuttings have failed to grow. Demerits: time consuming, expensive, unsuitable for large scale multiplication, poor rooting, varieties cannot be layered. Micro propagation methods. Conventional vegetative propagation methods like cutting, grafting, layering require a locally adapted variety for rooting to take place. They also take lot of time for establishment. They do not allow any room for improvement of the varieties. In order to develop new varieties as well as to propagate them in as short a period as possible and also in as large numbers as possible, new micropropagation methods involving tissue culture has been evolved. Propagation of mulberry. Mulberry is mostly propagated through cuttings. Cuttings may be planted straight away in the main field itself, or nursery may be raised and the sprouted or rooted saplings in the main field. The latter method is advisable because of its easy establishment in the main field. Selection of planting material. Generally, the mulberry plants are raised from stem hardwood cuttings. Cuttings are selected from well-established garden of 8 to 12 months old. Only full-grown thick main stems free from insects and disease damages, having a diameter of 10 to 12 mm are chosen for preparation of cuttings. The cuttings should be of 15 to 20 centimeter with 3 to 4 active buds and should have 45-degree slanting cut at the bottom end. Care should be taken to make a sharp cut at both the ends of cuttings without splitting the bark. Manual power operated mulberry cutter stem cutting machine is available for quick cutting of propagation material. Nursery bed preparation. Select 800 square meter area of red loam soil near water source for raising saplings for planting 1 hectare of main field. Apply 1000 kg of FIM to the soil. Raise nursery beds of 4 meter into 1.5 meter size. The length may be of convenient size depending upon the slope, irrigation, source, etc. Provide a drainage channel and avoid shady area. Pre-treatment of cuttings. Mix 1 kilogram of azospirillum culture in 40 liters of water. Keep the bottom end of the cuttings for 30 minutes in it before planting. Azospirillum is applied for inducement of early rooting. Nursery planting. Vesicular orbiscular mycorrhizae, its VAM, is applied at 100 gram per meter square of nursery area. Nursery bed is irrigated. Cuttings are planted in the nursery at 15 into 7 centimeter spacing at an angle of 45-degree. Exposure of one active bud in each cutting is to be ensured. Nursery management. Nursery is irrigated once in 3 days to avoid termite attack. 1 kg of endosulfan 4% dust or malathion 5% dust or quinalphos 1.5% dust is applied around the nursery bed. To avoid root rot and collar rot diseases, soil is drenched with carbon dioxide 50 Wp at the rate of 2 gram per liter. Using rose cane or trichoderma viridi is applied at the rate of 0.5 gram per meter square. After weeding, 100 gram of urea per meter square is applied between 45 and 50 days after planting. The seedlings are ready for transplanting in the main field after 90 to 120 days after planting. Main field preparation. The field is leveled first. It is plowed deeply initially using heavy moldboard plow, followed by country plow up to a depth of 12 inches to 15 inches in order to loosen the soil. The weeds and gravel are removed. FOM is applied at a rate of 20 tons per hectare irrigated or 10 tons per hectare in rain-fed. The manure is incorporated by repeated plowings. Planting is done during monsoon period. Winters and summer months are avoided. Some planting methods are pit system, row system, pad row system, collar system. Pit system is followed for rain-fed crop. Instead of plowing the entire field, pits of standard size, say 45 into 45 into 45 centimeters are prepared. Equal quantities of organic manure, red soil and sand are filled in each pit. After mixing, a sapling is planted, adapting a spacing of 90 into 90 centimeter. Row system is followed for irrigated mulberry. Ridges and furrows are formed. Spacing is 60 into 60 centimeter for rain-fed and 90 into 60 centimeter. This method is suited to high yielding varieties like V1. Paired row system spacing is 75/105 into 90 centimeter. Intercrops can be raised in the wider spacing. Mulberry cultivation in South India under rain-fed condition. Kanwa 2, S13, S34 are the popular varieties recommended for rain-fed, that is region receiving rainfall of 500 to 800 mm. South India, Karnataka, Andhra Pradesh and Tamil Nadu are the suitable region. Here, land for mulberry cultivation is ploughed deep with a heavy moldboard plough up to a depth of 30 to 35 centimeters. Thereafter, land is repeatedly ploughed 2 or 3 times with a country plough to bring the soil to a fine tilth. The land should be properly levelled. A basal dose of well decomposed farmyard manure FIM or compost is applied at the rate of 10 tons per hectare and thoroughly incorporated into the soil. The spacing commonly followed for a rain-fed garden is 90 into 90 centimeter. Pits of 35 into 35 centimeters are prepared. About 1 kg of FIM per pit should be applied. Cultivation in South India under irrigated condition. Kanwa 2, S36, S54, DD, MR2 especially in Tamil Nadu and Victoria 1 varieties are recommended for irrigated condition. Land for mulberry cultivation is ploughed deep and heavy moldboard plough up to a depth of 30 to 35 centimeters. Thereafter, the land is separately ploughed 2 or 3 times with a country plough to bring the soil to a fine tilth. The land should be properly levelled. A basal dose of well decomposed FIM or compost is applied at the rate of 20 tons per hectare and thoroughly incorporated into the soil. Plantations can be raised by using both cuttings and saplings. The varieties ideally suited for irrigated conditions are Kanwa 2, S36 and V1. Branches of 6 to 9 months old and about 15 mm in diameter should be used for the preparation of cuttings of 15 to 18 centimeter in length with 3 to 4 healthy buds for raising the nursery for planting directly in the main field. So, plant spacing of 90 into 90 centimeter is ideal for mulberry, 2 cuttings per pit to be used for direct planting. When using saplings, only 1 sapling per pit is used. Paired row plantation with the spacing of 90 plus 150 centimeter into 60 centimeter is recommended. Cultivation in hilly areas S1, S7999, S1635, S146, TR10, BZ259 varieties are recommended for the hilly regions of north and northeastern India. If the land has a gentle slope, it can be levelled by minor landscaping and providing suitable type of bunds across the slope. If the slope is greater, contour bunding, terrace planting or contour line planting can be adapted. In more sloping areas, platforms for individual plants or contour lines are more suitable since it involves less soil cutting. Spacing for free planting depends on soil topography, the extent of land available for cultivation and training method. For gentle slopes, 3 feet into 3 feet or 5 feet into 5 feet may be adapted. In sloping, more than 10 feet into 10 feet can be adapted. Pits are to be prepared for planting in deep textured loose soil 45 into 45 centimeter and in hard shallow soils 60 into 60 into 60 centimeter pits are to be prepared. For each pit 5 kg of 1 iron pan of FIM or compost must be applied. Recommendation for hilly areas, that is tropical highlands. Spacing should be around 90 into 90 centimeter. Some recommended inputs are FIM or compost 20 tons per hectare in one single dose in January or February. Acetobacter 7.5 kg in 3 equal splits. VAM inoculum 1000 kg in a single dose in lifespan plantation. Calcium ammonium nitrate at the rate of 200 kg in 3 equal split doses. Single superphosphate 156 kg in 2 equal split doses. Muriate of potash 84 kg in 2 equal split doses. Since the recommendations are general, qualities of fertilizers and amendments may be applied on the basis of soil test reports. Now, let us see the inputs for cultivation in temperate and subtemperate region. Goswami and China white are suitable for temperate, Chak Mazra and S146 are suitable for subtemperate regions. For Kashmir, 20 tons per hectare per year of FIM should be applied under irrigated condition, bush or dwarf tree. After the annual pruning in July-August and 300, 150, 150 kgs of NPK in 2 equal doses in April-May and in June-July. The expected leaf yield of this variety in Goswami and China white 15 to 20 tons per hectare per year, and for Chak Majra 20 to 22 tons per hectare per year. Mixed farming. Mulberry can be successfully grown as an intercrop medium mixed tree between rows of tea or coffee as shade plants. Besides providing shade, a substantial quantity of leaves can be obtained for silkworm rearing and for feeding cattle and goats. Furthermore, the pruned shoots are a good source of firewood. Mulberry can also be grown as an intercrop for cultivation in coconut plantation. A survey has shown that mulberry is intercropped with the coconut in the area of Channapatna, Ramanagaram, Kanakapura and Bangalore in the states of Karnataka. Insecticides or pesticides or fungicides and other inputs, DDBP or Nuvan at the rate of 1.25 liter in 480 liters of water, spray to control tukra and leaf roller. Washing soap, that is non-detergent type, at the rate of 5 kg mixed in DDBP solution. Ladybird beetles at the rate of 625 adult beetles are released for as biological control of mealybug. So, bionematicides, that is shell life of 180 days at the rate of 80 kg in 3 split doses for every 4 months during intercultivation operation to control root knot disease is applied. Neem oil cake 2 tons in 4 split doses every 3 months during intercultivation operation to control root knot diseases. Raksha shelf life of 120 days at the rate of 1 kg for 100 plants with 50 kg of FIM for root knot nematode disease is applied. Animal feeding practices and other traditional uses. Mulberry is known in India as Kalpavriksha. As all the parts of the plants have many uses, it is essential to sericulture as the foliage constituents the sole feed of the mulberry silkworm. Mulberry is a fast growing tree which, for the convenience of sericulture practices, is maintained as a bush. It produces very large amounts of renewable biomass in the form of branches, shoots, leaves and fruits. If mulberry is used for silkworm rearing, it is possible to obtain 30 to 35 tons per hectare of leaf every year. By growing mulberry, a farmer obtains fodder, fuel and fertilizer. With regard to fodder for animals, farmers in India feed their cows and goats with leaf over branches and leaves from silkworm rearing Many farmers feed their animals with surplus foliage, always mix it with straw. Farmers also use the mulberry branches for fuel after pruning. Leftover twigs are used to dry in the garden itself. Residues of rearing are also converted to valuable FIM for mulberry gardens by putting them in a pit for 4 to 5 months prior to use. So, to conclude, we discussed enough about the methods of selection of planting material, nursery plant and management in mulberry garden. We have also discussed about the animal feeding practices and other traditional uses of mulberry leaves. To summarize, mulberry forms the basic food material for silkworms, and bulk of the silk goods produced in the world are from mulberry silkworm. Sericulture involves agriculture, art and industry. Mulberry cultivation involves various farming practices.